Hello friends, I welcome you in lecture number 12 on vector calculus. From last 2 or 3 lectures we are discussing about line integrals. We have discussed how to evaluate line integral of a vector field f bar. If we remember, if we have parametric representation of a given curve C in terms of x, y and z, suppose r bar t is given by xti plus ytj plus ztk, then line integral of a vector function f bar along curve C with this parametric representation is given by we find out vector function at r bar t, that is we replace x by x of t, y by y of t, z by z of t in given vector function f bar, and dot product with dr bar by dt, and the integral is with respect to t, and limits of t will be from the parametric representation of given curve. So suppose t lies between a and b, then we have limits of integration from t equal to a to t equal to b. So we convert this integral into a definite integral of one variable t only, and we then integrate this dot product which will be a function of t with respect to t from t equal to a to t equal to b. So with this definition in mind, we will discuss this question which was asked in GTU Winter 2021 exam. If vector function f bar is given by 2i plus 3i plus xzj plus yz minus xk, evaluate line integral of this vector function along the path given by x equal to 2 times t square, y equal to t, z equal to t raised to 3 from t equal to 0 to t equal to 1. So we are already given a curve in parametric form, or we are given the parametric representation of a curve along which we have to integrate given vector function, and same question can be asked in this way also, as we have discussed in earlier lecture that this line integral of a vector function f bar gives us the work done by a vector function f bar in moving a particle along given curve C from one point to another point. If C is a curve between 2 points A and B, then line integral of a given vector function along this curve C gives us the work done by a vector field f bar in moving a particle from point A to point B. So the same question can be asked in this way also. Compute the work done by a force given by this vector field when it moves a particle from the point 0, 0, 0 to the point 2, 1, 1 along the curve given by x equal to 2t square, y equal to t, z equal to t cube. Here we can see our curve is having these three parametric equations x, y, z in terms of t, and this curve is starting from point 0, 0, 0. This is initial point and end point is 2, 1, 1. So here limits of t are not given, but it is given that we are applying a force to move a particle from point A to point B. So if limits of t are not given, we can find out limits of t using these 2 points also. For first point, suppose we compare this point 0, 0, 0, we have to decide that for which value of t this xyz will be 0. So that we can compare with these values of xyz, 2t square, t and t cube. So from this we can see that if we take t equal to 0, then we will obtain this point. So this points corresponds to t equal to 0. Similarly, we can compare end point B with this parametric representation. Suppose we compare 2 1 1 with this vector 2t square t cube, then we can have these equations. If we compare these first components, we have 2t square equal to 2, second component gives us t equal to 1, third component gives us t cube equal to 1. So all the equations will give us t equal to 1. From this we obtain t equal to 1. This will also give us t equal to 1, and from this also we obtain t equal to 1. So this point corresponds to t equal to 1. Therefore limits of t will be from 0 to 1 for this parametric representation. So if your question is asked in this way, you have to decide the limits of t for this parametric representation, and for that we can compare this xyz, that is x equal to 2t square, y equal to t, z equal to t cube, with both the points. First we compare this with this point, then we compare these values of xyz with this point, and we will be able to decide the range of t for integration. And here it is already given that this parametric representation is valid for t equal to 0 to t equal to 1. That is, for t equal to 0, you can see if I take t equal to 0, values of xyz will be 0 0 0, and if I take t equal to 1 in all these equations, I will have 2 1 1. So we obtain these 2 points when we take t equal to 0 and t equal to 1. Now we try to evaluate the given line integral. So we start, first we write down given parametric representation, given that curve C has parametric representation x equal to 2 times t square, y equal to t, z equal to t to the power 3, and limits of t are from 0 to 1. That means our vector r bar t is, we know that r bar t is xti plus ytj plus ztk. Therefore r bar t equal to xt is 2t square I plus yt is t and plus zt is t raised to 3. Let me check with given things. X equal to 2t square, y is t, z equal to t cube, and we will require derivative of this vector r bar with respect to t. So we differentiate both sides with respect to t. Here we will have to differentiate each of these components with respect to t. So here derivative is 2 as it is, derivative of t square is 2t, therefore we have 4 times t into I. Here derivative of t is 1, so we write 1j, derivative of t cube is 3t square. So this is d r bar by dt, and we will require our vector function in terms of t. So first we write given vector function f bar is 2y plus 3 xz yz minus x, 2y plus 3 times I plus xz times j plus yz minus x times k. Let me check again. 2y plus 3 xz yz minus x, and now we have to convert this f bar in terms of t. That means we have to decide what is f bar of r bar t. For that we will replace x by 2t square, y by t, and z by t cube. So we are using given parametric representation, this one, x equal to 2t square, y equal to t, z equal to t cube. So here 2 into y is t, so I have 2t plus 3 times I plus x into z, x is 2t square, z is t cube. 2t square into t cube, that is 2t raised to 2 plus 3, that is 5, times j, plus y into z, that is t into t raised to 3, which is t raised to 4, minus x is 2t square. So this is our vector function f bar converted in terms of t, and limits of t are from t equal to 0 to t equal to 1. So now by the definition of line integral, now integral of vector function f bar along given curve C is converted into f bar of r bar t dot product with d r bar by dt, and this we will integrate with respect to t from t equal to 0 to t equal to 1, and then we substitute values of f bar and d r bar by dt, which we have converted in terms of t. So first we put f bar of r bar t, which is 2t plus 3i plus 2 times t raised to 5 into j, 2t raised to 5 j plus t raised to 4 minus 2t square times k. This is our vector function f bar in terms of t, and then we write d r bar by dt, which we have converted in terms of t. Components are 4t, 1 and 3t square. 4t I plus 1j plus 3t square. This is d r bar by dt, and here I should write 3t square times k, and then we will integrate dot product of these two quantities with respect to t. Now we consider dot product of two vectors. We have to take product of corresponding components. Here first component is 2t plus 3, here 4t, so we multiply 2t plus 3 with 4t, that is 4t into 2t, which is 8 times t square, plus 3 into 4t, that is 12t. Then multiplication of these two components, which are coefficients of j, 2t raised to 5 into 1, which is 2t raised to 5, plus 3t square multiplied with t raised to 4, 3t square into t raised to 4, that is 3 times t raised to 6, minus 3t square into 2t square, 3 into 2 6 times t raised to 4, and integral with respect to t. Now we arrange all these terms containing powers of t. We first write down the highest power of t, which is 3 times t raised to 6. Then we write fifth power of t, 2 times t raised to 5. Then fourth power of t, which is minus 6 times t raised to 4. Then there is no third power, and after that second degree 8t square plus 12 times t. Integral is with respect to t, and now we integrate with respect to t. Integral of t raised to 6 is t raised to 7 by 7, 3 as it is. Similarly, integral of t raised to 5 is t raised to 6 divided by 6, and these two we can cancel out directly. So here we can write t raised to 6 divided by 3 minus 6 as it is. Integral of t raised to 4 is t raised to 5 divided by 5. 8 as it is. Integral of t square is 8t cube by 3 plus 12 times t square by 2, and 2 will cancel out with this 12. So we have t square by 2, 12 by 2 is 6, and limits of t are from t equal to 0 to t equal to 1, and now we put upper limit t equal to 1, which is 3 by 7. T equal to 1 will give us 3 by 7 this will be 1 by 3 minus 6 by 5 plus 8 by 3 plus 6. This is for upper limit, and minus lower limit is t equal to 0. So after this we have to take LCM of 5, 3 and 7. So LCM will be 105. 5 into 3, which is 15, into 7, which is 105. So here we have 7. So to obtain 105, we have to multiply this 3 by 15, because 15 into 7 is 105. So if we multiply by 15, we have 45. Similarly here I have to multiply by 35, so that I obtain 35 by 105 equal to 1 by 3. Similarly here I have to multiply by 21, and let me check. If I multiply by 21 with 6, I will have 6 into 2, 126, plus here again I have to multiply this 8 by 35. So here I have 8 into 3, 24, plus 4, so that is 280, and here I have to multiply 105 by 6, so I will obtain 630. And now we will sum all these quantities in the numerator, 45 plus 35 and so on, and you will obtain this addition equal to 864 divided by 105. And here we can divide this 864 by 3. Suppose we divide 864 by 3, we will have let me check what I will obtain. Here I will have 288. So this I can rewrite as 288 into 3, and here I can rewrite this as 35 into 3, and finally I have converted my answer into this 288 divided by 35. So therefore value of given line integral along given path C is 288 divided by 35, or we can say that work done by force F bar in moving a particle from point 0, 0, 0 to 2, 1, 1 along given curve C is 288 divided by 35. So here this is very easy. You just have to first convert your vector function F bar in terms of t, and you have to find out dr bar by dt, and then you have to take dot product of these two vectors. Okay, we first find out dr bar by dt in terms of t, then we find out, or we convert our vector function f bar. F bar is given as a function of xyz, and by taking xyz in terms of t, we convert vector function f bar in terms of t. Then we take dot product of these two vectors, and we obtain this function of t, of function of only one variable t. And this is the problem of single integration which we study in 12th standard. So we are converting our line integral into a definite integral which we study in 12th standard. Our line integral of vector function f bar is converted into integral of only one variable which we study in 12th standard. Integral of this dot product, which is a function of t only, and we integrate that function from t equal to a to t equal to b. So this is all about this session. I hope you like it. Thanks for watching.